All right, we're back. We're on page 5 of notes 15. We are talking about limits of Riemann sums, and we just successfully did one. And now we're going to try to successfully do another one. And actually, this one's kind of related. If you notice, this is the same function, but instead of being focused on the part that was like way over here, which gave us 88/3, we're focused on this little part. Now, think about it. This graph is below the horizontal on this interval, which means the answer we get should be negative. Like all the heights of all of our rectangles will be negative. Not going to impact us at all, but when we get our final answer, it will be negative. So keep that in mind. All right, let's look at this. Let's figure out the things we need. So we're going from 1 to 2, which means delta x is going to be 2 minus 1 divided by n, or just 1 over n. And then x sub I, so we're starting at the bottom, so we're starting at 1, and we're just going to add delta x over and over again. So it's 1 plus I over n. And then each rectangle is going to be the height, which is f of x sub I, times the base. Okay. And then how many steps did I break? I feel like I broke this into too many steps. Whatever. Let's do it. So f of x is x squared minus 3x plus 2. And then x sub I, we said, was going to be 1 plus I over n. Okay. Yeah, good to go. Let's do it. So we want the sum from 1 to n of, so it's f of x sub I, so parentheses, and now we're going to do f of x sub I times delta x and then like close a giant parenthesis. So everywhere I see an x, I need to replace it with x sub I. So 1 plus I over n squared minus 3 quantity, 1 plus I over n plus 2. Okay, I'm going to close this parenthesis and then times 1 over n. And then like technically I think I need this. I don't want to count those out, but I think I needed that. If you want to, you can highlight or something. What is this? Can you even see that? Ken, what are you? Ah, I don't know what that was. That was glitchy. And then this. It was like a perfect quarter circle too, just showed up. So I highlighted everything that's x sub I, so I can see it's like x sub I squared minus 3x sub I plus 2. That's definitely plugging into the function. So now we expand. I'm going to take out 1 over n because it's just in the way. You could actually start with it outside if you wanted to. All right, square the first. Multiply them together times 2. Square the last. Minus 3 minus 3i over n plus 2. That's part of why we take out that 1 over n, so it's not kind of in the way. So what happens here? It's just really nice that like you have 1 minus 3 plus 2. Gone. Don't need to worry about them. And then here you have a plus 2i minus 3i. So we can simplify this. And we should. You just want to like be going toward a simpler thing. So I think that's like universally true, but I'm not sure. Okay. Now I'm going to like break it out into, so I'm going to factor out everything except the I stuff, right? I'm taking negative 1 over n out. So I get negative 1 over n squared. My chair is like tilted back so far right now. Okay. 1 to n. Okay. I say okay every fifth thing I say. Okay. Cubed. So I'm hoping. All right, I think this is good because we have the sum of I, which is like n times n plus 1, but more importantly, it's like an n squared thing, and here an n squared. The sum of I squared is n times n plus 1 times 2n plus 1. That's like 2n cubed-ish over n cubed. We're on the right path, and that's like the really important thing. So here, I'm going to say this is negative 1 over n, and then the sum of I is n plus, oh no, the sum of n, oh, this n squared. n plus 1. It's like we just finished talking about it, and I was like, I guess I talked about it wrong. But I hadn't. My brain, I don't know. The amount of like data I've uploaded about me to YouTube just by doing these videos, can't imagine. Can't imagine what some computer in the future can do with that, so that's great. All right. I think that this is good. And now what we want to do to find the value that we're looking for, so we're doing the integral from 1 to 2 of x squared minus 3x plus 2 dx should be the limit as n approaches infinity of, so I didn't highlight this time, but maybe I should. So this part is where this part came from. And then this part is what this part came from. Just use like color coding so you can like see it as you go through. Now I'm gonna copy and paste because I can. And remember, we're expecting a negative answer because the entire curve was below the x-axis on the interval. And so if I get a negative, I'm not like surprised, I'm not worried about it, I'm okay with that. All right, we have essentially negative n squared over 2n squared. So we have like negative 1/2. And then we have 2n cubed over 6n cubed, which is basically 2 over 6, so plus 1/3. So that's negative 3/6 plus 2/6, negative 1/6. Negative 1/6 is hard to say, I think. And also, I mean, I don't know if I mentioned this in other videos, like some British people, I think, say like 6th instead of 6th. Like I'm saying 6th, and I think that they say 6th, like oh, I feel sick, 6th. Whereas I say basically the number 6th, and it's hard. I feel like 6th, if I could get my head around it, is actually easier to say, but I don't know. So I'll check that on the calculator. How do you go about making sense of your answer, which is a negative value? Yeah, it makes total sense to me. I mean, f of x is less than 0 on the interval 1 to 2. Actually, that's true. False. It's less than or equal to 0 because it's actually 0 at 1 and at 2. Therefore, negative makes sense, I think. But also, if this was a velocity function, so if it's the velocity, you have a negative displacement, which means you're just to the left of where you started at 1, right? So from 1 to 2, you move to the left, or from 1 to 2, you move down, whatever. All right, I'm gonna check this on the calculator. I'm feeling pretty good about it, but I'll check it on the calculator. Right now, the mic looks like it's working. So I'm really intrigued by what makes that stop. I suspect it has something to do with this calculator thing, but maybe not. I think f of x is stored. It is. So we can just do integral f of x. You should use the template, by the way. Like I think it's easier to type. Yay, we got it right. If you use the template, you just enter it so it looks like that. Could we do this the other way? We definitely could. We could do the sum. So this, I recommend you do this. Play around and just like get really good at like punching these things in. So it's f of 1 plus I over n times 1 over n. And then we took the limit of that. So this is like another way of confirming it, is to let the calculator do the same thing that you did. And we get this. By the way, infinity is in the pi key. I don't know if I've mentioned, I mean, I had to have mentioned that at some point in like math analysis, but I don't know if you're watching these because you also watch math analysis or not. So there you go with that. And yeah, so now the mic thing is not, it doesn't show that it's working. But I'm pretty sure it is working because I went back and I listened to the end of like a lot of videos and it seemed to be working. I wonder if, so I'm gonna experiment here for a second. I'm gonna hit mute and then unmute and see. If I don't come back talking, just know that I enjoyed working through these with you, and I'll be back in the next video to do more. But right now I'm gonna try to mute myself and then unmute myself. Okay, here we go. Okay, I just unmuted myself and it came back. Okay, so I think in the future, for my own personal peace of mind, I might do that. I might mute myself and then unmute myself just to like see the little thing bouncing so I know it's picking up the audio. Anyway, as I mentioned before, I enjoyed working through these problems with you, and I will see you in the next video. So yeah.